MBA ASAP. MBA ASAP. Hello and welcome to another episode of MBA ASAP, where we explore business skills and knowledge so you can level up your expertise and learn skill sets that will make you more valuable at your job and career, or help you start something on the side, a little side hustle, or let you quit your job and start your own business. I'm your host, John Cousins. Let's get started. Hi, and welcome. This episode is a freewheeling discussion of the world of computer technology and information systems. My guest is my son, Spencer Cousins, and he's been helping me to understand the arcane, byzantine, labyrinthine world of computer programming languages, coding, and all the infrastructure and how it all fits together. The internet, the web, front end, back end, full stack web development, all these kind of terms. My talks with Spencer have been incredibly enlightening to me and have helped me to get over some of the big humps of the learning curve, trying to figure out coding languages and computers and how it all fits together. And I really wanted to get him on the podcast because I think this information can be really valuable to lots of us. And I wanted to have him share his knowledge and his really great way of making these subjects clear and understandable. So this is sort of a wide-ranging conversation, and we go back and forth, and it's not in any type of necessarily a sequence, and only over time does all of the sort of ecosystem start to get comprehensible and knit together. If you know something about computers, I think it'll be a great way to just sort of geek out on it and learn a little bit maybe, and if not, it's a great way to get over this initial curve. This initial learning curve of where the heck to even start. You know, there are so many competing systems and developments are happening so fast that I found it incredibly difficult to know where to begin learning, how to continue learning, and what was the most important and fundamental pieces and how to prioritize them. So this learning curve can be really steep, and initially it's almost impenetrable. So much jargon and acronyms. Our world is so infused with technology and smartphones and the web and internet and computers and coding and programming that I felt really compelled to understand it better. The tools are available. I want to be taking advantage of them, and I think a lot of you may want to as well. So I hope that you find this really valuable. I mean, I've personally witnessed how Spencer's journey and the acquisition of these skills has transformed his life and his opportunities. And to whatever extent we do the same, we can all benefit. The other thing is that besides the ubiquity and the power of all this coding and what we could do when we know it, there's these incredible tools now to learn all these things for free. We have all these MOOCs, the MOOC, the massively online open courses through Udemy and Udacity and Coursera and edX, and just incredible courses that you can take, and Free Code Academy and Code Academy, and these are all great, and Khan Academy. I mean, there's all great tools out there. But when you start looking at all these tools and all the different choices of where you should start, you become paralyzed. It's like a Hobson's choice. There's too many choices. What I was hoping to do here is to have a casual conversation that kind of helps us all to start to get clear on the jargon and what is important and what maybe can be left to later. And maybe as we learn one thing, the next pieces will fall into place. And that's been a real challenge for me. So I wanted to share this with you. This is me and my son Spencer talking about computers. It's loose and casual, and you can hear my granddaughter in the background, River, and she's almost 2, and she chimes in from time to time, give her 2 cents on computers. So sit back, enjoy. It may be the kind of thing that you listen to a couple times to understand. I was going to put all of the terms that we use in the show notes, but then it just got to be too much. It's really quite dense as I listen to it. You can just Google these terms, and any ones that you don't understand, some of them you will, some of them you never heard before. If you just Google them, you'll get a quick explanation and can understand this stuff. So without further ado, enjoy this podcast on computers and coding and all the arcane, impenetrable jargon. So that finally it will be penetrable. It'll be clear. Enjoy. Catch you later. So yeah, I thought this would be good to talk about different, things with just with computers and computer science and programming and all that kind of good stuff.
Yeah.
And
it's becoming so huge as a part of our daily lives. I mean, everyone has a supercomputer in their pocket.
And there's River.
Hi, sweetie.
Well, yeah, exactly. And there's just all these languages and all the different words. Just like we were just working on GitHub, that as a place where you can store all your different code and work on it. And I'm just blown away. And it seems like it's broken down into a couple of different things, like the whole web thing with HTML and CSS and then JavaScript, and then on the front end and then the back end kind of thing with PHP and all. But now I don't know. Is that even worth learning SQL and PHP? Because that whole idea of JavaScript everywhere,
Yeah. JavaScript's really quickly becoming a universal language for the front end and the back end. Hey, going fast. So with Node on the back end, it just really opened up using the same language that everyone had to learn to use in browser technology.
Right, for the front end, and now you can use it for the back end and everything else.
Yeah.
So it's Node.js, huh? Is the,
yeah.
And was that a Google thing or something, did you say?
It was originally, yeah. It's the Google V8 engine. When they made that open source, then they were able to take that runtime engine that Google Chrome used in the browser and put it wherever they wanted.
Wow, so that they did it originally so that JavaScript could be used in the browser as a place to run the code actually in the browser, and then they thought, well, heck, why can't we deploy that on the back end too and all? And
yeah, I'm not sure if it was even an idea by Google originally. They might have just made it open source to, hey, it's a lot more effective for debugging and making like really strong software because you just have so many eyes on it. And because it got a lot of interest as being an independent runtime engine, they got to put it on the back end with Node. People started building applications with it, with Electron. So,
and this is V8, it's called? Is it the V8 engine?
Yeah, it's called the V8.
Wow, so making it open source. So right there probably it was like, if we make it open source, it'll probably take off in ways we haven't anticipated.
Exactly.
And so now it's become this huge... ubiquitous standard. And that's just amazing. And it makes so much sense. Instead of having, now you got to learn PHP and SQL and all these other things on the back end. And
yeah, exactly. That you can just access your database with JavaScript using Node and then make your database with JavaScript using Mongo and just using object notation to store all of your data.
And doing that, and then this whole idea, as we've just been seeing too, is this Amazon Web Services, AWS, and this Lambda thing where you can run, I don't know if I'm using the right term though, instances of the code, and if you use Java or whatever, JavaScript, and then that you don't have to put up any servers or anything like that, or even figure out how to do all the different parts. You just have it up there on AWS, and it'll scale as much as you need and stuff. And they give you, I think it's free, 1 million hits or something a month or something before you can even charge. It's just unbelievable.
Yeah. I've heard that can add up quickly with people doing home automation and stuff, and that like they end up running a lot of automatic hits to update their systems and stuff like that. So it's definitely, when you're first starting out, 1 million hits might seem like a ton, but as you scale up, it's, you hit that 1 million mark pretty quickly, is from what I've heard.
Oh, and that makes sense, yeah, because if you have 10 or 100 items in your house and everything is interconnected, my buddy's doing that. He's got he bought an Alexa so that he can automate his house. So I think they must have quick patches where you can, say like, Alexa, make it 66 degrees or
exactly,
whatever. Turn on the lights, and he's using this Philips light system, so he can turn on all his backyard lights and the lights in the house and all kinds of different things. It's like an intelligent clapper, the old clapper. Clap on,
right?
Clap off.
But now you just have it from your smartphone, and you can clap from the airport if you want to turn your lights on or off, or you're going on a trip and something like that. You forgot to turn your porch light on. You can automate your house from the road if you travel a lot, or if you end up going on vacation, or
view cameras and stuff that you have set up, like security
exactly.
cameras and stuff. In fact, yesterday I think it was, Amazon announced this new service where they're going to it's called Key, Amazon Key, where you allow them into your house, and as soon as you get into they get in your house, you have a camera that's on them, so you can verify that they're not destroying your house and all. And they can come in, and they're making different services like Merry Maids and all those kind of things available, so they can have people come in, and even think about when they start delivering food from Whole Foods or something, they can come in, populate your refrigerator. You don't have to worry about, all that stuff. And
then they're on webcam the whole time, and they know it. So
yeah, they're using webcam as a way to verify, why would you let scary people in your house? But when you think even of Lyft and Uber and all these other services like that, or Airbnb, like, I'm not going to go to somebody's house. They may be an axe murderer. All that kind of trust builds up pretty quick.
And I mean, this whole like cloud culture, I guess you could call it, this like prosumer culture, where individuals connected to the network are all contributing a slight amount. Like, it really started with YouTube, I feel like, with people making their own webcasts and things like that. And other people, someone who has a webcast will watch someone else's webcast, and it just creates this interconnected network of prosumers. And I think that culture is really spreading out to the bulk of society, as you see these like things like Lyft and Uber and Airbnb, where each individual is contributing like rides in my one individual car, or, you can stay in my back room, or I have a little casita in the backyard that I rent out, something like that they don't have to manage anything huge. It's just they're offering what they have personally. And that creates this huge ecosystem that you end up with a ton of value over.
Right, sort of getting out the latent value of these assets that we have, like our cars, that aren't used. So, well, we can use it for this, or even eBay, where you're selling your old clothes or furniture, all kinds of stuff, and it releases that latent value and all this stuff. Mm-hmm. And what did you call it? Prosumer?
Yeah, prosumer culture, like a producer consumer. Yeah, consumer producer. Something like
together.
Etsy, like craft culture, that kind of thing. Maker culture has really been growing.
Well, yeah, and Wikipedia, and then we can talk about
open source,
the open source, Linux, and all these kind of, or even back to the V8. You make these things open source, and people start doing. And it seems like a lot of the tools I see now are, this is an open source, blah blah blah, kind of,
it is, yeah.
Languages.
And that's what we've discovered is the open source. Well, it seems slow to start, that it's slow to get people to adopt, but it just grows and grows almost exponentially while it gains popularity. As people learn to use it, people can create new libraries in Python, for example, to like this whole data science with Python revolution that's been going on, as people make these libraries like pandas and SciPy for really like calculating these huge numbers that you could only use like MATLAB or other like scientific computing like C++.
So it's ways to access big data sets and for science and all? Cool. So Python has become the language for that kind of stuff
it's become access. Yeah, exactly.
Wow.
It's become really popular with data science, and is making moves. It's not there yet, but it's making moves to replace R eventually as the functionality increases.
I see. I thought R was more of a statistics program, but it's more of a accessing. So how would you do that? You'd use Python and then make a program, and somehow it would pull or slice and dice or access big data sets?
Yeah. So you can create programs to like do data mining, with Python that can grab the data off of other databases and other APIs and things like that. And then you can use Python libraries to analyze that data, to visualize that data, things like that, to do statistical calculations. Basically, every specific language that has come along to do these scientific purposes and things like that, as scientists learn them, and they also tend to know a bit of Python, they start thinking, well, why can't I just use Python to do all of this stuff? And that's kind of how these libraries are born.
Wow, so it's sort of like JavaScript taking over, well, I know JavaScript already, so let me use it in these other places where I have to do so. I know Python, so right. So scientists, I bet it'd be great for even astronomers and stuff. You can just
Absolutely.
say, oh, I want to search this quadrant of the of the universe data that's coming off of this telescope or something like that. And wow, very cool.
Yeah.
And so it's interesting. So learning, I mean, obviously, as basic skills, learning HTML5 and learning CSS, so you know how to do make a website kind of, the visual part of it, and then learning JavaScript, so you have all the programming elements for making basically full stack web apps or whatever, right? Those three things are good, and then Python is probably good as a language to learn, so that you could start crunching big data sets and get the big data part of things.
Yeah, Python's become a real centerpiece of data science, and it depends on where you're coming from. A lot of the time, sometimes people have previous data experience working more with Excel, working more with R, MATLAB. Oh, okay.
And Excel is SQL is kind of like an Excel kind of database setup. Is that what it is?
Somewhat. Yeah, it's like a non-rendered Excel spreadsheet in a way. It deals with its data in rows and columns.
Like
so
Excel,
it's very laid out the same way. But and you can get programs to visualize those tables and things like that. But where SQL really excels over Excel is doing cross references, so that you can have different tables referencing each other and referencing this ID, this name, this email, and going into more detail about that person.
So penetrating in the third dimension, across tables or something.
Yeah. So those relational tables is a big asset to SQL.
Excel has the pivot tables that are kind of, I guess.
That's kind of similar. And I think that works in a similar way. I haven't gotten into Excel pivot tables personally, but from what I understand, it works in a similar way, but it's just not as scalable that you can use the pivot tables up to a certain point, but where an SQL database can really easily, at a low level, make relationships between these tables.
And then to access SQL, you need PHP. That's the coding language for that.
Well, you can access an SQL database with a number of different languages, like Python, for example. The Django framework is great for doing backends, and that comes with SQLite for its standard database just baked right in. But it also has support for PostgreSQL and MySQL.
So that's the database, and Django is a framework that uses PHP, uses Python as the language?
Yeah, it uses Python.
That's Django.
And it's one of the more popular ones. Flask is very popular as well. It's a little more lightweight than Django. Django is kind of like a full, built-in templating agent, and it has a built-in server for testing, like a little lightweight server, so you can see if it's serving properly and things like that.
Wow. So, and those would be considered frameworks for back-end development, for back-end construction?
Backend Web Development.
Wow.
Yeah.
So for those kind of things, to use Django, then, say, you need to know SQL and Python. You'd have to be familiar with those guys. So those are good languages to learn. And then GitHub, obviously, is a great place to go and put your stuff, right? To go and keep your code, and then you can make... as you develop it, you can see the different iterations as you move forward. And so if something screws up, you can take a step back and you can collaborate with people and all.
Yeah. Yeah, there's a lot of great resources on GitHub too, as far as discovering new libraries and things like that, and getting the source code for the libraries that of these open source tools that other people have made, like React, for example, things like that.
So open source, and then take those and then modify them for whatever your purposes are, and you don't have to reinvent the wheel, kind of thing.
Mm-hmm. Or just download them to your machine, and then you can use them from your server, kind of thing.
Wow. And so what is .NET? Is .NET a Microsoft environment or something? Yeah,
.NET's the Microsoft environment, and so it's compatible with like C#. And you see a bit of like ASP.NET, ASP, which is, I believe, more of an open source. I'm not all that familiar with the Microsoft ecosystem, but from what I understand, ASP is the more open source side of .NET, where C# is the more like straight up Microsoft. And then there's also VB, which is a Visual Basic, kind of an easier language to get started with. It kind of is popular in certain circles and kind of not so popular in others. It's one of those languages that, you either love it or you hate it, kind of things.
So you got this whole C family. I mean, it's kind of strange that there's like Java and JavaScript, and they're like completely different, but they're kind of named the same. And then you have C and C++ and C++ and C#. Are they all similar, or are they like Java and JavaScript kind of named the same but radically different, things?
Yeah, I guess you could say that it's they're from the same family tree that as things kind of developed. I guess you could say that C++ and Objective-C are the two main operating systems of traditional like PC versus Mac architecture, that all of your programs or games or whatever that you would run on a PC would be written in C++. And everything that you would run on a Mac would be written in Objective-C. And they kind of kept the name C because C became really a popular universal mid-level programming language. Yeah. So they're like taking the ideas of C and then making them a little more robust with object orientation. That's where you first see like object orientation classes and things like that, is C++ and Objective-C. And as those progressed, Microsoft really got a lot more Java influence and wanted to make more of a Java-like language, and ended up making C#, which is really more akin to Java. So you see a lot of Java developers branching over to C# because the syntax is so similar, and vice versa. So that makes it a little easier as far as picking up professional developers for Microsoft. They can sort of poach the Java developers.
And Java then is more of a, what's the environment for Java, like Linux? Is that the?
Well, Java can run on anything. That was the big
write once, run anywhere kind of thing. Is that the deal?
That it could run on Mac or PC, and that's becoming less of a novelty. When you have technologies like Docker, you have Electron, where you're seeing JavaScript as a write once, run anywhere kind of technology, that it's seeming like that's kind of encroaching on Java's original scope, I guess you could say, of their original intentions. And what Java has moved to now, I would say most commonly, is Android development. All the apps on Android are written in Java. Even in that
CS50 class, that Harvard class, they start out with, first they start with Scratch, and then it's into C. So C is still, just regular old C is still popular, maybe just for the pedagogy of it, or is it popular for as a language as well? Or
it's really efficient as far as memory use and use of computer resources. So the Mars rover, for example, written in C.
Because you don't want to have any extra sort of housekeeping overhead or something.
You want to make sure that all of your calculations are done with the minimum amount of memory space possible. You want to make sure that you're using the most efficient use of your computing resources as possible. So it's popular with robotics and that kind of thing, where you need a little more efficiency.
Where resources are still kind of scarce or constrained. And that's another thing, it seems like, computational resources and storage resources and all, and bandwidth are all just like not as critical as they used to be because they're just so huge. The amounts. I mean,
the C was more popular when that was a bigger deal, and now as computing's getting cheaper, people are using more Python and JavaScript. And they're a little more wasteful, from a C perspective, they're a lot more wasteful of resources.
But from a developer perspective,
it's a lot easier to use these languages. It's a lot easier to write in these languages than telling the computer specifically how many bits you want for this particular calculation, where you want this pointer to point to in a specific memory block. It's a lot of things that you kind of roll your eyes and you have to be like, okay, tell the computer every little detail of what it needs to do. Whereas Python, you can just start cruising and it kind of does its own garbage collection and stuff like that is one of the major aspects of the higher level languages.
So where would you say would be a good place to learn Python? I mean, we tried that University of Virginia one on Udacity, which is really good. I may go back to that and try to.
Yeah, I remember, that was a lot of fun, and the idea of making your own search engine, is appealing. As a beginner, it's still appealing. That is a really cool project, and at the time, it interested me for a little bit, and then kind of fell off. I'm sure a lot of people have similar situations of you try to learn programming 18 times, and it's the 19th time that sticks, or something like that.
Well, that's what I'm the same exact way. Yeah, I just keep coming back, say I got to do it, and then I get a little bit, and then it sort of falls off or something. You get some momentum, and it wanes. But
as far as Python resources, there's a ton out there. A lot of people consider Python a great first language. I tried it as my first language. It didn't quite work for me. I went for C as my first real programming language. And some people need that. Some people need the lower level, but for people who can take the abstraction and have an idea of how programming works, in general, Python can be a great first language. There's Code Academy has a good Python resource. Udacity has some great Python resources. Udemy, Udemy's a paid service, but it's usually pretty cheap. And they've got some great Python sources. Coursera, I think they've got some Python for everyone, and then going deeper into Python for data science and things like that. And then Python can also be used in robotics. So there's some Python for robotics courses out there too. So depending on your interests and where you're coming from, there's a lot of different resources for Python out there.
Well, and like you said, the other one is edX with that CS50 course as a place introduction.
Exactly.
That's just really remarkable. It's the intro. It's the most popular course at Harvard, and really well done and put together. And you had said that C was where you first really got an idea about, okay, this is how programming works and stuff. And so it was good as a learning environment.
I just didn't have very much tolerance for abstraction. And it took me, honestly, learning how binary compresses into hexadecimal to have that aha moment of, they said, okay, this is how binary compresses into hexadecimal. We just did another step, a black box step, and we compressed the C into hexadecimal, which goes into binary. And I was like, oh, that. So it took me actually getting down to the actual binary to have that. Oh, that's what a programming language is. Yeah. So on the other side of it, it seems obvious, oh, okay, that's, but when you're looking at it from the outside, it's so confusing that I remember it was this big, just mind blown moment of what a programming language actually did and stuff. And that was kind of the my first big step, the crossing the threshold into really taking it professionally.
Wow, and that's very enlightening. That's what did it, and it came from C. And I like what you said about black box steps. That's the key. There's too many black box steps. I mean, the apps and levels of abstraction, they do that so that it's easier for a developer to develop and not, like you say, have to tell the computer everything. But to understand it initially, it's why am I doing this? And to get down to that level, that's really interesting, and that makes good sense. The other thing that I don't really, that I'm still trying to figure out, and it goes way back. I mean, because even when I started with Fortran and stuff, the terminal and the command line, that's all it was. I mean, before that, it was batch processing where you'd give a guy a whole bunch of cards and they'd put it in the card reader and that would zip through and then they give you a printed out reader. But then when terminals came along, suddenly you had this command line. And that seems so antiquated and old-fashioned, and now you have all these graphical user interfaces, and all other kind of tools that make it easier to interact with the computer. But it still seems like the command line is a very powerful tool, and that seems like C in a way, like sort of too close to the binary or something, too close to the machine. Sometimes,
and that's why developers love it, is because you are really close to the machine. And it gives you options that you can't click on. That nobody created a button for certain commands, but there are typed commands, and you can also do like bash scripting, command line scripting. So yeah, even when you said like, "Oh, the command line seems outdated," I like basically, I could hear the developers in my head just like squirming, being like, "The command line is super relevant." It really is.
Which is amazing that it's lasted. That's the one tool in a way that has legacy all the way back to the 70s and stuff when green screen terminals first came along. It's really remarkable. And we don't talk about even those languages. I guess C is the closest thing to a programming language from back then. I think that was developed at Bell Labs or something in the 1970s,
back 80s. In the 70s. Yeah. It's come a long way, and SQL is another good example of a technology that has stuck around. I think that was developed in the mid 80s, maybe. The version that we have now. And SQL in general has just stayed relevant for the past 45 years. It's really, as these other languages kind of come and go, and there's hype surrounding it, or things like that. That's SQL as a database system has really stuck around. But now we're starting to see a bit of disruption there with Mongo and the JavaScript object notation database structure, because that's really flexible. It's not these rigid rows and columns. It's just, you can add another attribute to your object. It's really no big deal.
Well, that sounds cool. And there's always this balance between the learning curve and what you know from a legacy thing that you already learned. Even with like typing, we still use the QWERTY keyboard, even though we don't need a QWERTY keyboard anymore.
Exactly,
Dvorak was much more efficient, but everybody knew how to type on a QWERTY, so then there's no mechanical constraints of speed or whatever to keep the QWERTY, but we did. And the same thing is like, do I want to learn a new language, or do I want to stay with the one I know? And just so you have these ones that this whole, as everybody learns stuff, it takes a lot of new features or a lot of benefits to get over that inertia of, oh my God, I got to learn a new thing, learning curve.
Exactly, yeah. And what is the trade-off? Like you were saying with Dvorak and versus QWERTY, it's like, I'm going to gain an extra 15 seconds a page in efficiency typing, but I'm going to have to spend 3 months learning be comfortable with this new key setup, And it is kind of the same thing of
not a big enough benefit for the cost of the learning.
Yeah. And that's why JavaScript on the back end has become so popular, is that typically the track was you start with front end development and you learn HTML, CSS, and JavaScript. And then you go into back end development, and you might learn PHP, like a Laravel or, Python Django kind of situation. And that you've got your back end. Ruby on Rails, really popular back end.
Oh, right. Ruby on Rails too, another.
But now it's kind of bringing those front-end developers to the back end so that they can bring their JavaScript experience there. And then you don't have to split your study time of be like, well, I'm like 70% good at JavaScript and I'm 85% good at Python. So, I'm stronger on the back end. You could just say, I'm this good at JavaScript, and it works. The browser,
the whole thing,
middleware, the back end, the database, everywhere.
Yeah, it makes great sense. Well, why don't we leave it there and pick it up again, and let me see if I can actually get this to
yeah, sure,
find where the recording is and all. But that was
this
great.
Is fun.
Cool. Really.
Sorry about River popping in and making a little cameo appearance.
Oh no, it's great. It's great. It should be just relaxed stuff, just talking.
Well, I'll catch you later.
Catch you later. Well, that's it for this episode. Thanks for listening. The show notes are available on the website. Just go to nba-asap.com and click on podcast on the menu along the top. And there you'll find all things related to the podcast. Just scroll down and there are links to the show notes for each episode. If you have any questions or suggestions, email me at john.cousins@nba-asap.com. And follow me on Twitter. I'm very active there. My handle is @JJCousins. And send me a connect request on LinkedIn. I'd love to connect with you there. And go to the website and sign up for the mailing list. Thanks again. Until next time, peace. NBA-ASAP. NBA-ASAP.